Hey everybody, this is Larry. This is day 25, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. Today's poem is a poem that we probably have solved a few times before. 852, peak index in a mountain array. I think in the past I've also do a drone video. I didn't plan on it, but actually I'm gonna retro add a drone video, so hope you enjoyed that drone video of me on a mountain. I don't know where it is yet because I have to look it up later. But yeah, all right. Leave me in the comments where you think it is. All right, so yeah, 852 peak index in the mountain away. Okay, so what's a mountain again? It's the peak, right? Okay, so given a mountain away, so it is already a mountain away. We turn the peak, basically, right? All right, n is 10 to the fifth, so I mean this is pretty straightforward binary search, right? So the idea here is that basically your mountain array looks like this, or your mountain in general will look like this, right? Like I don't know, am I showing it right? So that's your visualization, something like this, some slopey thing that, maybe it's not quite straight, but I cannot change my arms so that, it reflects that. But yeah, so basically the idea is that, okay, well, there are only two sides of the mountain you can be, right? You could be on the left side or something, depending on, I don't know how this, is this on the left side? Whatever, but you could be on the left side or the right side. On the left side, maybe it's going up, and on the right side is going down, right? So then now you're just checking the slope, and if the slope is sloping up, then you're on the left side, so you want to go to the right, and if your slope is on the right, you want to go to the left, right? And a lot of this is, of course, but based on that, there's a very binary search thing. Cool. So yeah, let's get started. And yeah, so the first thing we want to do is kind of figure out our bounds. So our bounds could be, I mean, we'll do I and I plus 1, so then this will have to be n minus 1 to be inclusive, right? So yeah, can it be on the bottom, or not on the bottom, but just like the last element? Maybe not, right? Can't. Maybe not. I don't know, right? So the way that I always say I do these with binary search is that I always make them inclusive bound, right? Which means that left is inside the possible range and right is inside the possible range. That means that left could be the answer and right could be the answer. And when they both converge to one number, then that is the only remaining answer, right? And then we do just, standard get the middle thing. And then we just basically go, okay, if, let's just say left, right? I guess we shouldn't use it. Maybe say on left, right? On mid. Then, so basically we're saying if this is on the left side, and we'll implement the function afterwards. If this is on the left side, like we're going upwards, then we're going to go to the right. If we're going on the right side, then we'll go to the left, right? And here, I know that I kind of hand wavy literally with my hands a little bit. But basically here we're checking I and I plus 1. What do we want the answer to be, right? So, and you can define however you like. It's just that these determines the like whether you get off by 1, in another way of saying it. But like, if so, the way that I'm going to just change set it, and you don't have to change it, you don't have to define it this way, is that I'm going to choose I'm going to try to find the last I in which I'm going to try to find the last I such that I plus 1 is bigger than I, right? So the last thing that's going uphill. Okay, so if this is true, then that means that left is a possible answer. The index left is a possible answer because I plus 1 is bigger. So we're trying to find, here, let's find the last number, or last index where O of index is less than O of index plus 1, right? So if this is sloping on the middle, then we want to, like I said, left is we want to keep mid still in the range, and that's why we set the left to mid, right? Because everything to the left of you're already on the mountain, so on the left is gonna be good. Otherwise, on the right side, so we can do right is equal to mid minus 1. And for round and arrow stuff, this is what we do, right? And then now we know that so at the very end, the loop invariant is that we end when left is equal to right. And of course that means that all of left index is less than to the left plus 1. Oh, I wrote this wrong, whoops, sorry. And yeah, and therefore the peak is left plus 1, right? So yeah, we return left plus 1, and that should be good. Now we have to write the on left, and this is actually pretty straightforward, right? Because we just return all of index less than all of index plus 1. Okay, so they guarantee that they're not Leetcode. That's why I'm just double checking, but because they're guaranteeing that it's gonna be a mountain, so that should be good. Let's give it a spin. Looks okay. I assume that there are no weird edge cases with respect to like last element and stuff like this because they guarantee it, but it's Leetcode and you can misread the guarantee sometimes. I feel like, alright, good, we're Gucci. Wow, I thought we've done it a few times, but I was lying. Probably the last time we did it was in Java in 2019. And I did it in a loop. What the past Larry, what are you doing? Was I just lazy? I don't know. Was I doing it for a speed thing? Wow, that is pretty lazy. I mean, alright, well, we don't need an explanation that one. But I think maybe I was just doing one of those like I was doing one of those speech streams where I was or maybe I took a random like, hey, let's do Java for fun and see if I could do it. And then I just did it lazily instead. Oh well. Anyway, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.